In this video, I'm breaking down the entire process of fine-tuning any LLM, whether you're training AI for customer support, content generation, or any specialized task. This video will walk you through literally everything you need for fine-tuning your LLM. So now you want to fine-tune your LLM because you want to change the default tune to make it more specialized and has specific custom tune that fit your business. I have listed the process into 6 main steps. The first one basically is choose the pre-trained model that you're gonna work on. And the choice depends on your use case or your situation. For example, in such cases like chatbot or any sort of conversations, DeepSeek Llama is the best choice. This is the market standards. So before choosing your pre-trained model, you have to check this. Step 2 is data preparation and formatting. Basically, at the beginning, you should have your own dataset or your own custom dataset that you're gonna train the model on or fine-tune the model on in order to change its tune or its behavior. And we can break down this process into 4 main steps. And the first one is to decide what is your use case or what is your need. For example, if the purpose of fine-tuning is to make your AI assistant more precise and more custom, you have to have dataset in JSON format. So data format depends on your use case. We have 3 common formats: JSON, CSV, and text. Step number 3 is to process your data, to remove any noise or any unuseful data. And step 4 basically is to split your dataset into train, test, validation. When it comes to this point, in this situation, we have 2 scenarios. The first one is to consider all the weights, which can be brutally expensive. And the second one is to select or use optimizer that add small trainable layers to avoid considering all the weights. So the first technique is simply full fine-tuning. And in this technique, we consider all the weights. So the algorithm count all the weights or try to update all the weights in your LLM. And this fine-tuning method is quite expensive because it counts all the weights. Second method is very well known, called LoRA, and it stands for low rank adaptation. LoRA simply adds small trainable layer instead of updating all the weights, and this reduces the GPU utilization or GPU usage by 10x. Can you imagine this? By 10x. So it reduces the required computations 10 times. And we have QLoRa, which reduces the VRAM usage by 50%. And it's similar to LoRa, but it works with 4-bit. Step number 4 is tokenization and model adaptation. Tokenization simply is the way of representing the text or the user prompt into the numeric representation, because machines doesn't understand the natural text or the natural language. So tokenization is the way of representing the text into the mathematical representation. And this is done by breaking down text into smaller units or tokens before feeding it into an LLM. And step number 5 is to configure our trainer. So after representing the text into tokens, or we can call it the process of tokenization process, now we're gonna feed all these numeric data into LLM in order to learn or fine-tune the weights. So it's a crucial step to configure the trainer. And Hugging Face is Transformers is the most used and the easiest trainer to use. And the last step is train your model. So I guess this is the simplest breakdown of the process of fine-tuning. So let's figure out how we can implement this in Python. So the first step is to install the required libraries that we're gonna need in the fine-tuning process. And then this is the process of loading the pre-trained model. In this tutorial or in this video, we're gonna use the 8 billion parameter DeepSeek. In this video, we're gonna use DeepSeek R1 8 billion parameter from Llama. And we're gonna limit the token size to 2048 to just speed up the training process and avoid any long token. And in this step, we're gonna implement the chat template to the tokenizer. And in this case, we're gonna use the chat template from Llama 3.2. And the reason why I chose Llama 3.2 is Llama chat format optimized for models like DeepSeek R1. And this is an example of the Llama format. As we can see, we have the user message like I'm highly upset because I failed in my math exam. Llama hasn't any padding handling, and padding simply ensuring that all the lenses of inputs is the same, which makes us avoid any tokenization errors. We're gonna use fast language model as optimization technique, which gives us 2x faster inference. This is the message format in our data. We have role, which is the user, and the content, which is the user prompt, like I'm highly upset because I failed in math exam. So this is the structure that the model gonna understand. And this is the part of tokenizing the chat input. This method right there converts the message into format that DeepSeek R1 can understand and deal with. And this line just converts the input to PyTorch format or PyTorch tensor for the GPU computations. And this attention mask is just to tell the model which part exactly is real and which part is padding. So padding tokens can be considered as 0, so the model will not look at. And this is the configuration of the output of the model. The parameter of it is quite simple. We have the input ID just passing the user prompts or the user tokens. We have attention mask to make the model avoid padding tokens. And we have max new token, which limits the length of the response from the model. And we have use cache with true value to make the process faster, and temperature with 0.6. Temperature simply is controlling the randomness in the LLM. And min b with 0.1 value to prevent selecting very unlikely tokens. And this is the decoding process, which means that we are converting the tokens back into natural text, like we can see there. And now it's time to apply LoRA adapter for efficient fine-tuning. This is the part of loading the dataset that we're gonna use. In this notebook, I have used the mental health consulting conversation, and it's kind of makes the model change its tune to fit this use case. So it's gonna be more familiar with people with mental health. So it's gonna respond with better way that fits this need, people with mental health. In this cell, we apply the chat template format to change the format of the dataset. As we can see, the text before formatting is not organized in the code way that we can understand easily, but after formatting, we can see it's more clean. So this is the reason why we need to use chat template or data formatting. Now it's time to configure our trainer. As I mentioned, we're gonna use transformers from Hugging Face because it's the most efficient trainer to use and the easiest. So we are just assigning the things that we have customized it above to the trainer to start training. And these are all the hyperparameters of that trainer. I will not dive deep into all these details. You can search and check about it. This training process ran for only one epoch, and I did this only for experimental purposes. And eventually, after finalizing the fine-tuning process for only one epoch, we can pass this prompt or this message content to the LLM to test. And this is why I have used the padding mask to avoid any padding tokens, which affects the process of tokenization so badly. So anyways, this is the user message, and this is the LLM output. And that's it. If you found this video helpful, don't forget to subscribe to my channel. See you in the next video.